Most of us, when we're first learning to write code, we begin with things like variables and we learn about functions or methods. And then we go into if statements and loops. And depending on your instructor, you may have classes and objects thrown in there. That's the way that I teach it, but many other instructors save those concepts for a little bit later. But all of those are what I would consider to be basic programming fundamentals. And when we get to arrays, we're now talking about what I consider to be the first sort of intermediate level concept. Arrays are our first data structure. So, a data structure is just a way that we can organize information in the computer's memory so that we can make it more efficient to work with. And arrays aren't the only data structure. There are lots of them out there, and in many cases, those other ones are more efficient choices or better choices. But arrays are where they all start, and it's where we should all start as programmers, in my opinion, because it ties together a lot of those basic fundamental ideas, and it also gives us the foundation for all the other data structure work we're going to do later on in our programming lives. So, what is an array? Again, when we first start programming, we begin dealing with variables to store our data. And the analogy I always use is that a variable is like a container where we can store one piece of information, right? So in this case, I'm using a can to illustrate that. And we can give that variable a name or an identifier so that we can refer to it in code. And whenever we use that identifier in our code, it's going to go out and look in that container and see what value is there and retrieve that for our use. Now, variables are really powerful. They are the again the kind of a building block for everything we're going to do, but they do have some important limits, right? Uh, a variable can only hold one piece of information at a time. So if I've got this container that's meant to store the name of a player and I put the name John Elway in there, well, if I come along later and now I want to store the name Peyton Manning, I can't put them in the same variable. If I put Peyton Manning in there, John Elway's gone, right? It only holds one piece of information at a time. I can make other variables, of course, and I can have a separate one for Peyton Manning, but that is a limit of the way we can use variables in our code. So this is where arrays come in. What if we have a whole bunch of information that's related that we want to store? We can think of that as like a collection. And so this would be like a six pack, right? So we can take a bunch of variables that are all similar to each other, and for some reason they kind of belong as a group, and we can combine them into one structure that we can work with as a single entity. So like a six pack, and those individual cans in there are still going to have the same limitations of a variable, right? It can hold beer or it can hold soda, but it can't hold both. But now we've got a way to start dealing with bigger data sets than just one piece of information. And again, we're going to use an identifier to refer to that, but the identifier is going to refer to the whole collection, not just to one part of the collection. And so that's usually reflected in how we name these, right? So a single container might be called player because it holds the name of one player. Our array, our six pack, might be called team because that's got the names of everybody that's on the team. Um, a six pack analogy is good for just understanding the basic idea, but that's not really the way that data is going to be organized in our computer's memory. So there's a more useful way for us to visualize it, and that's just this kind of table um, of of rectangles that we usually draw to represent our array. So we use this little kind of chart to visualize this. And again, we've got these variables that are grouped together, and each one can hold a piece of data. So in this case, each one can hold a name. And we're going to refer to each one of those spots in the array as an element. And so the rules here are that each element has to be the same data type, right? So I can make an array of cans, I can make an array of bottles, I can make an array of loaves of bread, but I can't have an array that has some cans, some bottles, and some loaves of bread, right? We have to determine that at the time it's created. The other thing we have to determine at the time we create our array is how many elements there are. And this is just because the programming language is going to, your computer is going to go out and reserve a chunk of memory for this array, and it needs to know how much space it's going to need. That's determined by the data type and the number of elements. So you have to set up all of that when you first create your array. So this array has 6 elements. Each one is a name. We probably are going to think of that as like a string, right? And our identifier here, team, refers to the whole array, not to an individual variable within that array. So we need a naming convention. We need a way to refer to those individual elements in the array. And we use index numbers for that. So these index numbers, they're going to start at 0 and they're going to count up from there. And what this means is that if I refer to the team array index 2, that in this case is Danielle, right? If I refer to team index 4, that's Javier, all right? So that's the way that we can organize this data and refer to the individual elements within it. And the total number of elements in our array is what we call the array's length. So in this case, our array holds the names of 6 different team members. That means it is an array with a length of 6. There's an important relationship between the index numbers and that length. And this is true in almost every single programming language. There are a couple oddballs out there, but certainly any that you're going to deal with in my classes. Um, the lowest index number in an array is always going to be 0 because that's where we start counting. And the highest index number, in other words, the last element in the array, is always going to be the length minus 1. So if the array's length is 6, the highest or last index is 5. This is something that is often, I don't say confusing to beginners, it's not a hard concept, but it's really easy to confuse when you're writing code. So what this means is that team index 0 is valid, team index 3 is valid, for example, team index 5 is valid, but if I try and refer to team index 6, that's a problem because there is no such thing in this particular array. So we always have to be aware of the length of our array and where those limits are for the indexing. Now, the next rule when we're working with arrays, or the next important concept that we need to understand, is that arrays are immutable. Now, the word immutable means you can't change it. In the case of arrays, we mean that in kind of a specific way. So we can change the contents of an array. And by that, what I mean is that these individual elements, we can change the value that is in those elements. If I have Jesse that wants to be part of the team and is going to replace Danielle, who's injured, I can do that. Okay. I can make that kind of a change to the values stored in the array, but I can't, for example, change the data type. I can't all of a sudden put in a frog instead of a person, for example. I don't know why I picked that example, but the data type in this case holds the name of a person, so that's what I have to put in there. Those kinds of changes are okay. The kinds of changes that aren't okay are changes to the array structure itself. So if I have a player named Isaiah, I can't add Isaiah onto this team by just adding another element. Once I have created the element, once I've created the array, it has reserved memory for that exact size. I can't just decide I now want to make it bigger or smaller for that matter. There are some tricks we can do. I mean, it's not a hopeless situation. What I can do is I can make a new array that's bigger. I can make a new array that holds one more person. I can copy all the old data into that array. I can put the new piece of data into that extra element at the end, and then I can change where my identifier name, team in this case, points so that it now refers to this new array. And if you're using a managed language like Java or C# or something, it will then kind of get rid of that old array and free up the data. So this can give us the illusion that an array can be changed, but it's actually a pretty involved process. This is something that we would refer to in programming as an expensive process, meaning it takes some computing power to do that. And that's just the nature of arrays. If you're going to be working with a collection of data that's going to need to change a lot, let's say you need to keep track of your little sister's friends, and there's always all kinds of drama. They're fighting with each other, and somebody's kicked out of the group, and somebody else is brought back in, and you're going to have to be constantly changing the size of this array and moving things around. Then an array probably isn't the best choice. You probably going to want to use something like a linked list or one of those other data structures that are way beyond our scope here. But there are options out there. The last thing I want to mention is the close relationship between arrays and loops. An array by itself is really useful and really handy to have around. It can save us from making a whole bunch of different variables and we can just make one. But what really unlocks their potential is when you start using loops to process them. The most common type of loop that certainly that we'll use when you're working with me is what I call a traversal loop. And so a traversal loop is when we just want to go through the entire array. So we're going to go through and just do something with each element. It could mean that we're going to just output the name of each person on the team, kind of create a roster. If it's a bunch of numbers, we could be going through and adding them up, something like that. But a traversal loop is a loop where we're going to start at 0, we're going to end at length -1, and we're going to increment for each iteration doing something to the loop. And you'll see how to write these kinds of loops, and you will write so many of them that they will become second nature. So, arrays are going to give us our first chance to deal with collections of data or bigger amounts of data, which is really what computers are so great at and what really makes them so powerful. At this point, you are now ready to go off and start writing some code using arrays, which we will take on in a separate video.